For number 17, once again, we're making a scatter plot. And it's important to make the scatter plot first so we can see what kind of an equation we're trying to deal with here. I'm going to put age down here once again, and I'm going to put the number of hairs over here. So age, it starts around 2, so I'm going to do 2, let's see, 4, 6, 8, 10, 12, 14, 16, 18, 22. Okay, so I just went by ones here, labeling every other. My hairs, I'm going to start somewhere around 20. And I've got to get somewhere around 100, so maybe I'll go by 20, 30, 40, 50. That won't quite do it. Might have to go a little bit steeper here, so maybe I'll go by 20s. So I'll make this 40, 60, 80, 100, and then this would be a 120. So now I just plot each of these points. So I've got 220 is right here. 652 is right around here. Oh, sorry, went a little high on that one. 652, there we go. 1076, right around here. 1495 is right around here. 18100 is right around here. And then 2292 right around here. So when I look at this, obviously it's not forming a line this time, so I kind of imagine this as an equation. It looks like it's forming some kind of curve, maybe a parabola. It's kind of like a quadratic, okay? So this time, instead of doing a linear regression, since I have a curve and it looks like I'm following some kind of quadratic, I'm going to do a quadratic regression this time. But the process is essentially the same. I'm going to take my calculator. I'm going to be punching in these x and y values. So I go back to stat. I calculate. I'm going to clear each of these lists just like I did before. I'm going to punch in my x values, the 2, the 6, the 10, the 14, the 18, and the 22. Again, I don't punch in the 50 because that's the one I'm going to be predicting. And then I punch in the y values that go with these. Okay, so I've got all my ordered pairs punched into the calculator. I go back to stat. I go over to calculate, and I go down to number 5, the quad reg. Okay, and once again, after I go down to quadratic regression, I tell the calculator to calculate, and it gives this, me this equation in my standard form. Let's keep that off to the side just a little bit. So it gives me y equals, the a value is about negative 0.3 x squared plus 11.13 minus the c value, which is a 0.231, looks like. Maybe I'll round this guy to a 0.31. Let me get this guy off to the side so I can write this a little bit bigger. So again, I'm doing this. Y equals a negative 0.31. I keep running into this guy a little bit. Negative 0.31 x squared plus 11.13x minus the 2.31. So this is the equation that I'm going to use. So I'm going to go back and I'm going to plug in the value that I'm looking for. I need to make a prediction about this. So I'm going to plug this in. So I get somewhere around a negative 220.81. All right, so it looks like I've donated my hairs to science. Okay, easy enough. Taking a look at the next one. Now I'm going back to graphing a little bit. To graph inequalities, again, I ignore the inequality until I'm ready to graph here. So this one is just a line. I've got a y-intercept of 2 and a slope of 1. That's up 1 over 1. Then I look at the inequality and I see that there's no equal to condition, which means I use a dotted line instead of a solid line. And then I just have to decide which side of this graph I'm going to shade. So I pick a point. I pick something like 0, 0, and I plug it in. If I plug a 0 in here and a 0 in here, it gives me the statement 0 is greater than 2, which is false. So instead of shading the side of the line that had 0, 0 on it, I'm going to shade the opposite side of the line. So I jump over here and I shade this side of the line. Okay, so I shade everything over here. Because 0, 0 didn't work, it means my solutions are on the opposite side of the line. And I shade it in. For number 19, I've got an absolute value. So again, I look at the vertex, which is 1, 3. So I've got 1, 3, which is right here. I know that this thing is going to open down because my A value is negative, and it's going to be my standard width, which is over 1, down 1, over 1, down 1. For this one, there is an equal to condition this time, so I'm going to use solid lines. And now I just need to decide if I'm going to shade inside or outside of this V. So I pick a point again. I pick something like 0, 0. If I plug 0, 0 in, I get 0 is less than or equal to. 0 minus 1 is a negative 1. Absolute value of that is 1. I get a negative 1 plus 3 is a positive 2. So I get 0 is less than or equal to a positive 2, which is true, which means I shade this side of the graph. So I shade inside the V. Okay. For this last one, I'm graphing this quadratic. So again, I need the vertex here. So I do the opposite of V over 2 times A, which is 2 over 2, which is 1. That's the x value for my vertex. I plug that back in to get the y value, 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3, which is a negative 4. So I've got 1, negative 4. And in terms of graphing, I also see my y-intercept is right here, is a negative 3. I can reflect that point. I know that this thing's going to open up. It's going to be my standard width. And really, that's enough information to graph. You don't have to do much more than that. This one, I'm going to use a dotted curve because there's no equal to condition. But really, I just need a quick sketch of this thing. Nothing too involved. So now I've got the sketch of my parabola. It's a dotted curve. Now I just need to decide, am I shading inside or outside? So I pick a point like 0, 0. I plug it in. That gives me 0 is less than a negative 3, which is false. 0 is greater than negative 3. So I shade outside of the parabola. I'm shading everything on the outside. Okay. For the next couple, I'm essentially doing this same thing, except I'm only looking at the x-axis. So for this first one, I ignore the inequality sign and just look at x squared plus 8x plus 12 equals 0. And I solve. I solve by factoring. I build a bridge. Two numbers that multiply to 12 but add to an 8 are a 6 and a 2. So that gives me an x plus 6 and an x plus 2. And I set each of these equal to 0. So I find out that x equals a negative 6 and x equals a negative 2. And then from here, I've got to put this on a number line. So I plot this on a number line. I've got a negative 6 and a negative 2. And I'm just going to choose some values here. Now I recognize that it's an inequality. There's an equal to condition, so I'd have a closed dot on each of these. And now I just need to decide if I'm shading inside between the 2 points or outside on the outside of the 2 points. So I pick a value. And the value I would probably choose is 0, which is over here somewhere. And if I plug 0 in, I get 0 is less than, or sorry, if I plug a 0 in, I get a 12 over here, is less than or equal to 0, which is false. So since this point right here didn't work, and that point's on the outside, instead of shading the outside, I shade the inside. Okay, so I shade everything in between. And what that means is I have an and inequality, which looks like this. Negative 6 is less than or equal to x, less than or equal to a negative 2. And that's my answer. Okay? So I use the graph to write the inequality, not the other way around. Same thing with this last one, x squared plus 3x minus 4 equals 0. If I build a bridge. I solve by factoring. The two numbers that multiply to a -4 but add to a +3 are a 4 and a -1. So it's an x plus 4 and an x minus 1. I set each factor equal to 0. And I solve each. Here I find out that I got a -4. Here I find out that it's a 1. And now I've got to graph it. -4 is down here somewhere. 1 is up here somewhere. Again, 0 is somewhere in between. So that's the value I'm going to plug in. I don't have an equal to condition this time, so I know I use open dots here. When I plug the 0 in, I get -4 is greater than 0, which is false. So instead of shading inside where 0 is, I shade everything outside. I'm shading in this direction and in this direction. Okay. So what I have graphed here is an OR inequality. I've got x is less than a -4, or x is greater than a +1. And that's my solution. Okay. Hope this was helpful, and good luck on your test.